recording? Hi guys, this is Mrs. Johnson here, and this is my son David, and we're going to do the rock cycle lab with you today. So let's look at the tools that you need. You need crayons, and we've already pre-shredded several piles of crayons. You want to use at least 3 to get some different colors. You need a knife for shredding. You need a pair of kitchen tongs, and you need a piece of aluminum foil, and that should do it. So we are going to be going over the 3 types of rocks in the rock cycle. Who can name for me the rocks in the rock cycle, the 3 main types? David, do you know any names of rocks? No? All right, there's 3 main...
A diamond?
A diamond is a rock, but do you know any of the bigger categories of rocks? No. There is igneous, sedimentary, and metamorphic. So we're going to start with a parent rock, and this one is going to be igneous, and we're going to apply some weathering to it. Now, David is using the kitchen knife to shred the crayon into tiny sediments. So this is representing the weathering. So he's going to make some sediments. You have to, let me show you for a second here. You want to just gently, put your hands down there, gently shred it. You're not digging into it. It's just a little peel kind of thing happening. Just kind of like you're peeling bits of chocolate off like that. Chocolate curls, if you're in a kitchen, if you've ever made chocolate curls. All right, so we've already done a lot of this work. So I'm going to just lay this parent rock right here, and I'm going to put this knife right over here for out of the way so we can see. Okay, so we've got
yellow, pink, blue, red.
All right, we've got all those different kinds of sediment. And remember, weathering can be caused by wind, water, ice, and then weathering is the breaking apart of the rocks into tiny bits. All right, now, then there's that word erosion. Erosion is the moving of rocks from one place to another. So David's going to help me with that. So we've already weathered our rocks. And remember, tiny bits of rocks are called what? Do you remember? Sediments. All right, so we're going to use this piece of foil here. We're going to fold it in half here for a second. We're going to lay it down right here. And then David is going to represent erosion. All right, so David, I want you to pick up the yellow pile there and put it right here in the middle. Okay, let's kind of squish it here in the middle. All right, let's try to get all of the yellow bits. David, do you know what these tiny bits are called now? Were you listening? What are they?
Sediments?
Sediments, good job. All right, let's put all the sediments there in the middle. Okay, now, if you'll notice, the sediments are different sizes, right? Things don't weather uniformly. So we've got some bigger chunks here and then some smaller chunks. All right, so this was erosion. He picked them up and then he laid them down here. Does anybody remember what the word is for the depositing of sediments? All right, deposition, guys. So we have weathered, eroded, and deposited the sediments. Now, David, I want you to pick up the pink ones and put them on top of the yellow ones. Okay. All right, let's get all the pink ones. All the pink ones. Making a pile. All right, I'll do the blue ones.
Can I do the red ones?
Yeah, you can do the red ones. All right, so we're going to put all of the sediments, we're depositing them in a pile. Okay, so there are 3 kinds of sedimentary rock. The first kind that we studied in our lecture was clastic. The second kind was chemical. And the third kind was organic. So with these, what kind do you think we're making? Are we evaporating water from a solution? Nope. So that one is chemical. And then remember, organic is remains of plants and animals that are smushed together. And so that leaves just clastic. And examples of clastic were sandstone, mudstone, and conglomerate in Brescia. All right, now we've got our sediments here, and sometimes, you know, when things are deposited in a river or in a flood, you do get some organic material mixed in. So I'm going to put a couple little tiny pieces of paper left over from peeling the crayon. And these tiny little pieces of paper represent shells or bones, some fossils in our rock here. All right. Now, we've got deposition, and now we're going to go through the process of making a sedimentary rock. So what are the two things that you need to make a sedimentary rock? What's going to make that into a rock? What do you think, David? It's going to be your favorite part. All right. Compaction and cementation. Compaction is where the weight of the layers push down, push down, push down, push down, and then the gaps between the sediments get smaller. All right, and then cementation is when water flows through. The water's got minerals dissolved in it, and then eventually the water will evaporate from those spaces, and the minerals will glue the tiny pieces together. So we're going to do compaction and cementation to make this sedimentary rock. And so what we're going to do is we're going to make a little packet here. We're going to fold up the sides. All right, and we're going to fold up the other sides. All right. Okay, now you are going to be the smasher. Just make your fist and smash it as hard as you can. Do it again. Again. Well, not that hard. That's going to bruise yourself. All right, here. Do it again. That hurt? Okay, do it on that side. All right, you have to do a lot of pressure to get this crayon to stick. So if you need to, you can put this on the floor and step on it with your foot to get a lot of weight on it. You can do that. You want to try that? Okay, let's see if it works. All right, it may not stick exactly to each other. Let's put it up here. Let's not put it on the floor. Because we haven't cemented it, right? All we've done is compacted it. So it's going to be real loose, but it should have formed something of a little rock here. All right, and it did. You did a good job smashing.
I think I know what we're making, a crystal.
Oh. Okay, so I'm going to take a tiny bit of this, all right? And can you get a close-up of that? All right, this is what we're going to be calling our sedimentary rock. We didn't cement it together with anything. All we did was compact it. But the process for sedimentary rock formation is compaction and cementation. So I'm going to set this sedimentary rock right here. And then we are going to now take some of this and put it into a, not yet, take some of this and we're going to put it into a foil boat. I'm going to use this one. A foil boat that I already made. And you make the boat by taking your foil and rolling up the sides and going round and round and round and round until you get this. It takes a little bit of time, so I went ahead and pre-made one. All right, so we're going to take our sedimentary rock here. It's a little bit crumbly, a lot of crumblies. All right, well, here, I'm just going to put some of our smushed up rocks here. I was trying to save time. Okay. Now, what we're going to do with this is now we're going to create a metamorphic rock. All right, and metamorphic rocks, remember, require both heat and pressure. The rocks are not completely melted. They're just warmed, and then it can be chemically active fluids flowing over them. Think rocks in volcanoes and places where plate boundaries are coming together. So there's heat and there is pressure. So we're going to apply some heat. So David, come on over here, buddy. All right, so the other tool I didn't tell you that you need is you need a little pan of water. And we're not going to completely melt this. We're just going to let our little boat sit in there for a minute. And I heated the water up to boiling, and then I turned it down. And so it's hot but not boiling. And we're just going to let it sit there for a minute or so. So let's review metamorphic rocks while we're waiting for this to melt. Remember, metamorphic rocks can be foliated or non-foliated. And what that means is how the crystals are arranged. If the crystals are arranged in parallel bands, that is called foliated. And those types of rocks will break along those bands, and you get sheets. Think about the slate that we talked about in the lecture notes. Also, the other examples we had were schist and gneiss. And the gneiss really shows the bands because they're in parallel layers, kind of like a zebra. And the other type is non-foliated, marble and quartzite. The parent rock for quartzite is sandstone, and the parent rock for marble is limestone. So once the heat has been applied and the pressure to the limestone or the sandstone, they become quartzite and marble. All right, I need the tongs, David.
Can I use it?
Let me do it, buddy. Okay, Beth, can you get a close-up of this? You can see that it started to melt in the bottom, but it's not completely melted. Like if I scoot it around, you can see it's a little melty, but not completely melty. And that's what we want, because we don't want it to completely melt. So now, what we're gonna do is we're gonna take this guy here, and then we're gonna put the other one as like a lid on top of it. And then David, it's your job. All right, come smash again. So we've had heat, and now we're gonna have pressure again.
Enough?
Nope, more.
No.
More. All right, that probably did it. Okay, so now we should have our metamorphic rock, and you might need to let it cool a little bit before you peel it off in real life. So when you get it, you should see that it has really solidified. It's swirly. You see it's changed. It's smooth again like a crayon, melted on the bottom there. So I'm going to set the example of the metamorphic rock right there next to the other one. Okay, so when you look at this, you can you get a close up of both of those? All right, so the sedimentary rock, you still see lots of crystals, lots of grains. And this one, they've melted and become smooth. But you can still see the other parts still are in it. So it's rearranged itself. Okay, so cementation, compaction, heat, and pressure. All right, and then our last type of rock is igneous rock. And we started with an igneous rock, right? But we're going to completely melt this one. I'm just going to put it back in this boat here. Here, that's a better piece. Look how pretty that is, guys. How swirly it looks. Think about pieces of marble that you've seen. They got swirly patterns in them too. All right, I like that piece. All right, so we're going to keep that piece here. And then we're going to put this back in our thing. Okay, so sedimentary, metamorphic, and we are making igneous. Now igneous has to be completely melted. All right, so that's going to take a little bit. So let's talk about igneous rocks then while we're waiting. So igneous rocks form from molten rock, and there's two kinds of molten rock, right? There's lava, and then there is magma. And what the difference between those two rocks is location. So if you remember from the lecture notes, what is the name for molten rock that's under the surface of the earth? Think in your head. Magma. Now, if it's on the surface, then we use the other word, lava. Now, when the rocks are forming, oh no, I got some chemically active fluid in my boat. Oh, okay. There's water, right? Think about deep sea vents. There. Rocks don't melt without a little bit of water sometimes. My boat is sinking. I'm going to just hold it with the tongs while we talk. Okay, so if the magma inside the earth cools, it forms what's called an intrusive igneous rock. And it's going to cool very slowly inside of the earth. And so the crystals are going to be really, really big. And the example that we had in the lecture notes was granite. And granite is that rock, that's used for countertops, it's used for tombstones. Remember, it's got the white, the pink, the black. All right. Now, if it cools on the surface of the earth, which is what I'm modeling here, it's going to cool pretty quickly. And it's called extrusive igneous rock. And the crystals are going to be fine-grained because of the rapidness of the cooling. And the example that we had in our notes was basalt. And basalt is the rock that builds continental plates. We're going to learn about plate tectonics in 2 weeks. And so we'll learn more about basalt then. And then granite is the rock that forms the continental plates. I still got a little bit of water in there. That's some nice looking lava. Look at that. All right, I am going to drain the extra water out of the... There we go. Okay, so you can see it's already pretty much cooled there. I'm still not quite wanting to touch the foil. Let me see. It's okay. All right, still a little cool. It's like melty chocolate right now. But you can see that it's completely melted almost. There's still a little bit there, but all the colors mixed together. And now we're back to an igneous rock. Let me see if I can. Yeah, it's still melty chocolate. I think I'll have to let this cool a few more minutes before I can peel it off. So I am just going to lay it over here to the side so you can see all three. Now, if you decide to do this at home for extra credit, I need a picture of you with your 3 different kinds of rocks. I don't want just a picture of the rocks. I need the picture of you and your rocks. And you need to have the sedimentary, the metamorphic, and the igneous. You definitely need to ask your parents before you do this because you are going to make a bit of a mess. And you absolutely have to clean up the mess, right? Your mom definitely doesn't want to clean this up after you destroy her kitchen. So you need to be safe with this. Kitchen tongs, a knife, a couple crayons, aluminum foil. And I use this paper, parchment paper, just to kind of contain some of the mess. So when I go to clean this up, I'm just gonna put these in my sink and then roll all this up, okay? So follow safety guidelines, guys. When you're doing this, be careful. And if you do it, make sure that you post your picture in the discussion post so that everybody can see what you made. All right, that's it. Thanks for watching, guys.